Okay, Dan. Well, welcome everybody that is following today this second UCAR Africa initiative seminar. My name is Ana del Moral Mendez, and I'm a postdoc at UL here in NCAR. I'll be hosting this session with Wenfu Tang from ACOM, that is also in the call, and Kelly Nunez, that is going to be helping with the Slido questions at the end of the presentation. So our speaker today is Dr. Roelof Bruintjes, project scientist at the Research Application Laboratory here at NCAR. And he's going to talk about the problems, challenges, and opportunities in implementing early warning systems for Africa. Dr. Bruintjes received his PhD in physics at the University of South Africa in 1992, while also working as a weather technician and forecaster at the South African Weather Service. He's now a project scientist 3 at NCAR, where he has been working for the last 30 years. Also, Roelof was an affiliate professor at the University of Arizona until 1997 and an honorary professor from 2001 to 2009 at the University of Witwatersrand in Johannesburg in South Africa. He is a principal scientist and project leader on weather modification programs and aerosol cloud interactions here at NCAR, and his research includes cloud physics, radar meteorology, weather modification with a special emphasis on precipitation enhancement, cloud processes, and aerosol cloud interactions. Roelof has partnered in projects in 19 countries around the world, including Rwanda, South Africa, Mali, Burkina Faso, Senegal, and Kenya within the Africa territory. Roelof, thank you so much for being our second speaker in this seminar series. Just a reminder, you'll have now 45 minutes to present your work, and then we allowed some time for the questions for the audience. And for all of those who are in the audience connected online, please submit your questions for Roelof through the Slido. And then Wenfu and Kelly will help to read those questions for all of us. Roelof, welcome, and the virtual floor is yours.
Thank you, Anna, for the nice introduction. Yes, I was born in South Africa, and I just calculated today, I think I visited every country in Africa except 6. So during my career, we've had projects in North Africa, West Africa, East Africa, and Southern Africa. So today I want to talk a little bit about especially early warning systems. I will focus primarily on Southern Africa and Rwanda, where we have a long history, where we are also working on a new NASA Severe program to implement an early warning air quality forecasting system with Rajesh Kumar and others. I wanted to talk a little bit about my experiences in working with the National Hydrometeorological Services, but also with some of the universities in Africa. The problems and the challenges and the opportunities of implementing early warning systems for Africa. I think there are a number of challenges, and maybe problems and challenges can be combined in one. But the vulnerability, the map that you see in the first slide here, just shows the maps of the vulnerability, and I will talk a little bit about that in the context of Rwanda and South Africa. You can see that if you look at it from a global scale, that the highest reds and the largest area is really covered in Africa, where most of Africa has vulnerabilities. And especially in central, the tropical region of Africa and the subtropics are highly vulnerable, and many different things, droughts, floods, fires. One of the projects that I was involved in was the Safari 2000 NASA project, where we started biomass burning in Southern Africa. That brought me to all the Southern African countries. So I will talk about that also. The population density, like for instance, in Rwanda, basically has the highest population density of any country in the world. It's one of the very small countries, but a very high population density. And you can see that basically all over Africa, there are large amounts of vulnerabilities. My talk is primarily in the context of what was put forward by the United Nations last year, when the UN Secretary General Antonio Guterres on the tasked the World Meteorological Organization on the World Meteorological Day. Today, 1/3 of the world's people, mainly in least developed countries and small island development states, are still not covered by early warning systems. And this is especially applicable for Africa. This is unacceptable, particularly with climate impact sure to get even worse. Early warnings and action saves lives. And to that end, today I announced that the United Nations will spearhead new action to ensure every person on Earth is protected by early warning systems within 5 years. This is a very challenging situation. And I want to talk a little bit today about also how the World Meteorological Organization is tasked to do this. There are large amounts of fundings through the SOFT program of WMO, GBON program, and then logically many of the funding agencies like the World Bank, like the African Development Bank, and other international NGOs and private funding organizations are participating in this. And so I think NCAR and UCAR can play a major role in all of this. And how we can play a role, I'll talk a little bit about that further. So the overall part of early warning systems is really a value chain, trying to provide value, not only in saving lives, which is logically the most important, but also in terms of economical impact, because many of the disasters that happen in these countries do have a very large impact on the GDP of those countries. So like in terms of the value chain, we're talking about weather and monitoring and observations, modeling, forecasting, dissemination and communication of your forecasts, perception and interpretation, user decision-making. And I think at NCAR and also in the Research Applications Laboratory, we have a long history of doing this kind of work. And also then the economic and social impacts that are really important. So this whole chain is really important, and how do we bring it together as we develop programs in Africa? In terms of elements of an effective early warning system, I think first of all, logically in each country, you have to have the risk knowledge. If you don't know what the risk is, you don't know where to put your instruments, your observations, and you cannot really do a good forecast if you don't have to look where your risks are. For instance, for example, if a certain basin or watershed floods more often than others, you want to make sure that you cover it with your instrumentation so that that can be assimilated into models and better predicted. Systematically collect data and undertake risk assessments. This is a continuous effort also in the context of climate change. Monitoring warning service, develop hazard monitoring and early warning services. And then how do you disseminate and communicate that to the communities? Many of the communities in Africa and the developing world in general don't have all the facilities and don't have all the, can be sometimes very remote, and how you can do that. In some of the countries, you need sirens. Other countries, you can do this via mobile telephone networks, but many of these break down during disasters. So you have to come with new innovative ideas on how to address this. And then the response capability, training the population, the vulnerable communities, how to respond to any type of disaster or any type of warning. So all these 4 components are extremely important of an overall early warning system. It's not only just about monitoring, observations, and modeling, but all these social aspects and are as important as sort of the main aspect of this. And I think this is very important to consider. I want to start off with a current program in Africa, and Rajesh Kumar is the PI of this program. I am participating in this. This is quality motivation. 398,000 premature deaths related to air pollution in Africa. Very little to no air quality information available in most parts of Africa. And we'll get back to that later, because Africa is not a data-rich area. Air pollution episodes arrive unannounced because there is no system to alert the public of forthcoming pollution episodes. And this is especially true for forest fires and the smokes from forest fires and grassland fires that do occur often in Africa. This just shows a picture of some of the PM 2.5, PM 10, and ozone over Africa. And you can see there is large variations and sometimes very high concentrations of these, depending on where you are. And this depends on the season, logically, because during the rainy season, the air is more clean. Rain is the washing machine of the atmosphere. But during the dry season, pollution levels can quite suddenly intensify in many of these regions. So natural hazards and risks. These are some statistics from 1980 to 2020. Natural disasters in South Africa, either droughts, floods, storms, have led to significant social and economic losses, which is anticipated to exacerbate as consequence of climate change. During the period of 1980 to 2017, about 100 disaster events were reported, resulting in more than 2,200 deaths, as well as 21 million people affected, and totaling roughly 4.5 billion monetary loss to the countries. And I think, although this number may seem relatively low from US standards, this is very high from the developing world standards. So these are available in the climate change portal. Now, if you look at these bars, you can see that the blue is in droughts, the black is floods, the green is storms, thunderstorms. Most of Central Africa and the subtropics are primarily dominated by convective storms, while the southern part of South Africa can get frontal systems, and the northern part. And we also know about last week the tremendous flooding with the storm in the Mediterranean Sea that killed more than 2,000–3,000 people in Libya. Earthquakes is the orange color. Then you have wildfires in darker blue, purple, extreme temperatures, and then landslides and epidemic. And what you can see is that droughts, storms, and floods really stand out. To a minor extent, earthquakes and extreme temperatures. But the large problem in Africa is really droughts, flood, and storms together to some extent with the wildfires. And this is also a seasonal aspect that you can get. So these are the kind of disasters and risks that many parts of Africa are experiencing. If you look just from another pie chart type of thing, perspective, you can see that storms and floods are really making up the major part of it, with wildfire and droughts a smaller part. There are some miscellaneous accidents. So in the 2000, for instance, in the 2015 and 16 El Nino disrupted the agricultural season, with major parts of Eswatini, Lesotho, Namibia, South Africa, Zimbabwe declaring drought emergencies, and this drought cycle lasted for some years. Prolonged droughts have impacted food security, especially in these underdeveloped countries. For example, in the 2018-19 agricultural season, about 10.8 million people were affected by food insecurity. And this has happened in Zimbabwe and other parts of the countries. At the moment, we are again in an El Nino, and these things can happen potentially again. And this is important to consider. If we just look at natural hazards in Southern Africa, and I'm talking here just a little bit about the recent history, the recent KwaZulu-Natal floods in South Africa on the East Coast was one of the most recent natural disasters in South Africa. Severe flooding and landslides hit South Africa from April 1 to April 13. This resulted from extremely heavy rainfall in most part of the country. Combined, the floods and the landslides caused more than 448 people, the death of so many people, and displaced more than 40,000 people. Additionally, more than 12,000 houses in the country's southeast part were destroyed. Another aspect, these are floods, and this occurs often. In 2018, South Africa experienced its worst drought in recorded history. While the drought began about 2 years earlier, it reached a peak in 2018. Some regions in the country experienced soaring temperatures and inadequate rainfall from 2015 to 2018. As a result, crops failed and hundreds of thousands of cattle and wildlife died. By 2018, and we all remember this, Cape Town, a city of, at the moment, 8 million people, was dangerously close to what is known as day zero of disaster, where the taps were going to be turned off because they didn't have any more water. So basically, the rain started about a month later. But these are kind of warning systems in terms of climate change, because this can result in great disaster. Had the city reached that point, the millions of residents who live there would have been without running water at all. And I think all of us can imagine what that would be and the effects that that could potentially have. In terms of forest fires, the forest fires in Knysna forest fires were the most destructive in the history of South Africa's wildfires. This was in 2017. The fires began in early 2017, fueled by strong winds from the Cape Town storm. The winds blowing at more than 90 kilometers an hour made it incredibly difficult to contain the fire. By the time the fires were extinguished, they had displaced more than 10,000 people and destroyed over 600 houses. And then also, South Africa has recorded more natural disasters than any other country and other African countries since 2012. What natural disasters occur in South Africa? Some of the most common ones, including flooding, storms, drought, and persistent lightning strikes off the Indian and Atlantic Ocean coastlines. So these can affect, to a large extent, shipping also. What I want to talk about a little bit is the Global Climate Risk Index, the CRI, quantifies impacts of extreme weather events in terms of fatalities and economic losses. Heavy rainfalls in East Central Africa have had a disastrous consequence for infrastructure. And you can see in the table there, we list some of the ranks. You see Mozambique is #1 in the world, Malawi #3, Zimbabwe #14, Burundi #15, Kenya #62, and you can go down the list there. So this affects agriculture, food security, precipitation, floods, and landslides with a major cause of this damage. Climate change may interact with other pre-existing stress factors and developing changes to exacerbate vulnerabilities concerning the access to fresh drinking water, health issues such as malnutrition, sanitation, and diseases, as well as issues with human security. So in this sense, you can see actually the fatalities also. If you look at the table there, you get the CRI rank, and then the fatalities in 2015, the losses in US dollars, and then the losses per unit GDP. So you can see this oftentimes can range close to 1% of the GDP, and in larger disasters, even more. The economic and social impact. Rwanda, and now I'm turning a little bit more to Rwanda to show you that the same is happening in Central Africa. Rwanda suffers 5 major hazards, including drought, landslides, floods, earthquake, and windstorms. The combined assault by disasters cost the country a massive 100 billion Rwandan franc, which is about 132 million US dollars, bigger than the budget allocated to the agricultural sector alone. A senior environment, Magda Loet, and disaster management official at the World Bank, suggested that the government of Rwanda should develop capacity for prediction of changes in precipitation and extreme weather events and natural disasters, through better hydrometeorological forecasting capacity and systems. And this is also one of the things that we are working closely with Rwanda at the moment. And then at least 200,000 Ugandans are affected by various types of disasters. And again, she said that the disasters negated gains in poverty reduction and development. So this is also another social impact that these disasters can also hamper the development and basically bringing the population out of poverty. It is estimated that for every dollar spent on preventing and mitigating disasters, save an average of $7 in humanitarian disaster response. So these are the sort of the motivations, and I will have 2 more slides on this and then move on. Over the past 2 decades, floods, droughts have affected over 2 million people. The research estimated total economic loss due to flooding in Rwanda alone to be about 1.4% of the overall GDP for the 2011-12 fiscal project. In Rwanda, floods affected people's lives and properties, where only from January to April 2018, in some regions of, these are regions in Rwanda, 50,000 people were displaced, 116 deaths and 200 injuries, 1,200 houses and 33 bridges were destroyed due to the flood. This happened again at the beginning of this year, where again, several hundred people were killed due to floods. In December 2019, on Christmas night, the city of Kigali was punched by heavy rain, which flooded the city. According to the flood list, 12 people died, 113 houses were destroyed, and the rain affected the supply of water within the city. This is where the WCRP conference will be held in October. And then also from a report from January to December 2020, disasters from hydrometeorological events such as floods, landslides, lightning, windstorms, and hailstorms caused 278 deaths, 396 injuries, 8,000 houses. So we can go on with the numbers, but you can see that these are numbers that we do not see in the Western world when these kind of disasters occur. And this is primarily because they don't have the capacity to warn their population oftentimes in these types of situations, and the purpose also for the big push to get early warning systems involved. If we look a little bit at the agricultural sector, the agricultural sector is the primary source of employment, the main driver of income growth, and the dominant sector for revenue generation, domestically, regionally, and international markets. And this is for Rwanda true. However, Rwanda's agricultural sector is also exposed to high levels of existing climate variability. And so most of the agriculture is rain-fed. Irrigation is done on some extent, but on a very small scale. The Stockholm Institute in 2009 found that Rwanda was not adequately adapted to existing climate risks, that climate change could cause additional net economic losses of at least 1% of the GDP. And all these numbers are not only true for Rwanda. I can go through every country in Africa and collect all these kind of numbers, but this gives us a motivation for the implementation and the work that needs to be done. Risk analysis categorized Rwanda at high risk in terms of climate change vulnerability due to limited capacity to respond to disasters, high poverty rates, and reliance on rain-fed subsidence. So is this a problem just only for Rwanda? No, and this is a problem primarily of infrastructure also. This is an article from Bloomberg in 2021. Africa is the continent without climate data. So Africa is at the moment the world's most data sparse continent. And we will talk a little bit about that a little bit more. What weather data infrastructure is in Africa is deteriorating fast. So it's not only that Africa, the monitoring systems that are in place are also deteriorating, with only 22% of the stations meeting global reporting standards in 2019. And this was an article in Bloomberg. Another graph that I can show here is basically the availability and quality of weather climate data in Africa. As you can see, this graph provides an average number of stations in Africa, and from 1901 to 2013. And what you see in this graph is that basically the peak number of stations peaked in the early 1970s, and after that it has gone steadily down. And this is also a problem in terms of maintenance, in terms of quality control, and then also data dissemination. This is a major problem that we'll address a little bit more in the future, in the next few slides. So aviation is also a very large growing area in Africa at the moment. It is anticipated that this aviation in Africa will grow tremendously in the next 2 decades. Rwanda is building a brand new airport. Qatar Airways owns 49% of that airport, and they are planning to make this a hub throughout Africa. To achieve economic and social development as part of Vision 2020, the landlocked country has invested heavily in its national carrier, airport infrastructure, and capacity building to connect the country to markets overseas. A vibrant aviation sector also facilitates tourism in country and other countries in Africa, which is its first foreign exchange earner. Rwanda receives over 1.3 million tourists in 2015, earning $318 million. Rwanda's airports have over the years had a consistent annual passenger traffic growth rate of 13%, indicating the need to consider expansion. And so they have developed a master plan. The overall investment in aviation infrastructure is estimated at $789 million in 2019 to 2030. And as aviation grows, weather needs for aviation will grow also, because Africa is a lot of 9 months, 10 months out of the year, you will have thunderstorms in the region with associated wind shear. And so it's a major hazard also in Rwanda and many airports in Africa. And they have very little in this regard. Even in South Africa, Johannesburg, Oliver Tambo International Airport, they have no wind shear warning system even in place, one of the biggest airports. And very few of these airports have them in place. So before I go into a few other slides, I wanted to talk about the World Meteorological Organization, the global GFCS climate systems assessment of weather services. So the WMO assesses weather services, and they basically define 5 core functions or pillars. Those are 1, observations and monitoring; 2nd, research, modeling and prediction; 3rd, climate services, information systems; and then 4th, user interface platform, and then also capacity development. And then these, the National Hydrometeorological Services, the NMHSs, are then categorized in 4 different categories. 1 is basic climate services, which means a very basic service. 2 is essential climate services. 3 is full climate services, and 4 is advanced climate services. Now, most like the US and Western European are at number 4, but by and large, 80–90% of the African countries are at the level 1, so where there needs to be a lot of improvement. And this is basically the 5 pillars that I mentioned in the previous slide, and then going back to the users. So WMO periodically does these assessments of all the weather services in the world, and this is in South Africa or in Rwanda specifically. I can show here, according to the Rwanda, is then also basically as a category 1 and the lowest category that you can get. And the ranking was based on the fact that Meteor Rwanda's participation in national climate policies and plans is limited, lack of research development unity, a limited number of specialized employees, a lack of upper air observations, unmodernized user interface platforms, and old worn-out systems. And then basically suggesting that that needs to be strengthened, its governance, improve capabilities of its staff in specialized areas, and expand its training programs. And this goes very much for our Africa initiative also. To deliver vital meteorological, hydrological, and air quality services, it should invest in technological capabilities, including software, high-performance computing, upper air, marine observations, numerical weather prediction, climate modeling, and air quality modeling and predictions. And we are only starting to scratch the surface of these kind of things. And one of the things that we come across, and this goes for many of the African countries, the infrastructure and monitoring has improved over the past 10 years, but sustainability is the largest challenge. There are many NGOs, many World Bank projects and Development Bank projects that are coming into these countries and installing automatic weather stations, installing weather radars and other monitoring equipment. But it's unsustainable because these countries don't have the capacity or the funding to basically maintain these systems. So a lack of integrated database, and the other thing is a lack of an integrated database to collect and archive data sources from different hydrometeorological networks, surface and remote sensors, including data sets that are housed in other agencies. In many countries in Africa, the hydrology is run by the Department of Water Resources, while the Weather Service is in the Department of Environment. And those two agencies oftentimes don't talk to each other, or there is very little interaction between each other. So this is important to operate an efficient early warning system. Maintaining, calibrating, and improving the quality of existing data sets is limited. Lack of high-performance computing facility to implement new hydrometeorological forecast models for short and longer-term local and regional predictions is limited, and oftentimes do not do data assimilation or any of those kind of parts that are important for getting a good forecast. Then also in terms of the governance of these hydrometeorological services, RMA as Rwanda meteorological agencies, to improve the capability of its staff in specialized areas and expand its training program, and then investing in technological capabilities, including software, high performance computing, upper air. And it's really important also for our African initiative to have more homegrown African researchers and local science needed to capture the regional dynamics. I think one of the large parts is that many of the World Bank and other funding agency projects, they run for about 3 years or 4 years or 5 years, and then everybody leaves and leaves nothing behind. So we really need to think in terms of a coordinated manner and a holistic manner, where we work together with educational and other institutions, but also to make sure that this is a coordinated effort. Because many of the World Bank projects, there are tenders for radars, there are tenders for automatic weather stations. In some of the countries, they have 3 or 4 providers, different automatic weather stations with different formats. And all those things provide extra problems. Also, many of the weather radars that have been bought in Africa last for about 5 years before they don't work anymore because of the maintenance and unsustainability of the project. And so what is an integrated system? And I think this is also how we have to look at this, because we can focus on one component, but all these components are important in terms of creating a sustainable system with capacity building, training, and education, just as important part of the whole system. Although many countries in Africa have acquired new stations, meteorological equipment, such as weather radars over the past 20 years, most of them struggle to maintain and operate them. In many of the countries, less than 50% of the stations are operating. In addition, many lack the information and communications technology, the ICT infrastructure, to be able to receive, process, quality control, and disseminate the data. This shows an example of all the automatic weather stations that are in Rwanda, and I've come across this in Latin America also. This is a tremendously high density of automatic weather stations. But at any one time, only 20% of them are reporting. That 20% is not always consistent. So some stations stop at certain periods to report, and then they start reporting. Again, here, the maintenance, how the data quality is done. So these are kind of things that we need to do, because unless we have good data, we need to coordinate in how we can solve these kind of issues. Oftentimes, it's not a matter of just buying more instruments or putting more instruments in the field, but it's more a matter of how do we keep getting existing stations to work properly and supply the data properly. Because this is in many parts. Oftentimes NGOs will buy some stations, the agricultural department will buy some stations, the meteorological department will buy some stations, but it's oftentimes not coordinated. And this goes back to some of the regional and the funding agencies. In one of my experiences, and this was in Latin and Central America, the World Bank, the JICA, the Japanese Institute, USAID, the European Union, all had projects in the hydrometeorological field. But when we talked to them on the World Bank project, we brought them together in a meeting, and this was the first time they all talked together. So I think as much as we work with these countries, we need to talk with the funding agencies and the NGOs to try and coordinate these efforts so that there are no duplication, but also to help in doing the sustainability of the thing. This just shows a map of the radar coverage of the KwaZulu-Natal floods, where 400 people died. And you can see some black markers here, all the flooding, and this was the radar coverage I show in the circles, but the black circles is where there was no radar coverage. So there was no forecast of this flooding. There was very difficulty to forecast this flooding, and many of the stations that they had didn't work at that time. So this is an example of, they do have stations and they oftentimes do have some radar coverage, but the warnings are very limited. Numerical weather prediction. On the modeling and the forecasting side, the problems are also significant, with many countries lacking the computing resources. Yes, and then it's also difficult to put a high-performance computer in those countries without the human capacity and the training of doing this. In South Africa, SADC, the Southern Africa community, bought Dell servers for collecting climate data. They installed it in Zimbabwe, but in 2-3 years, it never worked. So the human capacity is as important, not only from a meteorological or a scientific point of view, or a hydrological point of view, but also from an infrastructure, ICT system. From that perspective, you need engineers, you need technicians, and you need software engineers. Even when they run regional models, it is often done without data assimilation from radars and automatic weather stations. Especially in convective environments, it's extremely important to assimilate radar and to ensure clouds and storms are well represented in the models during initialization. This makes forecasting very challenging, difficult, especially while most of Africa is dominated by vector systems. Cloud computing is one potential, but some of these countries are also reluctant to start with cloud computing, and there are social, political type of issues in that regard. For instance, Rwanda has a law that unless the cloud computing, the cloud source or the cloud computing is a resident in Rwanda, they do not allow to use the cloud computing. So there are social and political type of implications also. It is important to think about this also, to consider providing early warnings for any of these events would require an integrated modeling system that couples the atmospheric components with each of the hazards. And I think this is something that we have at UCAR in terms of the WRF models suite, in terms of WRF Hydro, WRF Chem. And those are kind of things that needs to be put together. In many of these projects in Africa, we have different models from different institutions all over the world running, but there is no interactions between these hydrology and the atmospheric models and the air quality and the atmospheric models. So these are kind of things that I think we at UCAR have an advantage and could potentially make a major contribution. Capacity building, I talked about that, and including, I think, needs to include the private sector. In South Africa, for instance, there is now a private company that is helping the weather service in maintaining some of their systems. And I think this is very important because building the capacity of the weather services, we need to work together with the private sector so that the economy can be developed in those countries also. And this is where the public-private partnership that WMO is also supporting is really important for the future. Salaries are much lower in the public sector than in the private sector in Africa. And oftentimes when you train people, they would move to the private sector. So these are kind of challenges that needs to be looked at and needs to be addressed in terms of how do we get sustainability. Here I'm just highlighting that although we are working there now in air quality, aviation, lake forecast and strong winds on some of the lakes, hydrology, energy and renewable energy, air quality, agriculture, health and tourism are all facets that needs to be that are part of all these early warning systems. And I think one of the most, in my view, the most important part is training and capacity building with educational standards and universities, but working closely with African and trying to get African grown scientists that can work at their universities also. Disaster response. This is an extremely important component, informing the population for response to natural disasters. At the moment, there's a lot of training going on in Rwanda to do this. And then also, basically, this shows another slide of some of the other work that we have done in South America recently, in terms of also informing the local population. And they can also oftentimes help you in what are the real risks and where is the risks and where is the flooding occurring. Computing facilities, I talked about this. This is an important part. Logically, first choice would be the cloud, but if it is not possible, how do we help these countries in terms of developing this capacity and this capability also? Climate variability and change impacts the uncertainties on water resources. And so this is a major problem in Africa. Fresh water, quality water, and then logically, because of the cycles of rainfall, all the different structures that come into place. And this is basically meteorology, hydrology, all the different components together with chemistry involved in that. Then also the global framework for climate services. There are many of these information systems, but if we don't have the data, it's very hard to do basically climate impact studies and those kind of things. So in terms of the public-private partnerships, there's three different types. The private sector, the business, either for profit or commercial enterprises that helps the National Hydrometeorological Services. Also engagements or other public agents with the private sector in various modes in the production and delivery of climate and hydrology data. And I think here the emphasis is on the private sector, building up the private sector in Africa, but where with help maybe from the private sector in some of our Western countries. And then also collaborative work between the private sector and both the public in an ongoing way. This may consist of a specific single activity or may evolve into a set of actions or even enduring alliance, building consensus and ownership with each collaborating organization and its stakeholders. So these are important things that has to be considered in all this. Why is UCAR-NCAR maybe the perfect organization to lead this? Long-term experience in applied science research, including development of early warning systems at multiple spatial and temporal scales. We have a deep fundamental knowledge of NWP, air quality, including source attribution and hydrology models, along with data assimilation, calibrate probabilistic prediction systems, real-time verification tools, and post-processing, connections with many national meteorological and hydrological agencies in the world. And we do have a lot of connections all over Africa at this moment already, even with the hydrometeorological services. We are experienced in tailoring forecast products to end user needs, and also a strong emphasis on training and education, which is, I think, should be a very important part of our Africa initiative in working with educational institutions, but also the training centers that are associated with the hydrometeorological services. Challenges and potential solutions for the lack of computing, identify computational efficient techniques that can help stakeholders. Lack of capacity, developing comprehensive capacity building program. One of the programs that we can work with in Africa is I think it's an area of mathematical sciences that bring in professors from foreign countries for a period of a year to do certain trainings. Funding, I think we can look at many different, there are multiple funding agencies, and especially if we work closely with WMO, but the Green Climate Fund, we have a funding project with NASA, USAID, World Bank. I think we need to take this message to all of these in terms of really looking how the funding can be coordinated and with a focus on sustainability and long-term sustainability for that part. Many of the other countries, Meteo France is very active in Africa, so there's a lot of other people that are active in this field, but it's at this moment largely fragmented. And I think this needs to be understood by the funding agencies in terms of how do we not go into fragmentation, but how can we coordinate all these effects to have the best impact for Africa. And then also logically for international programs, we have at NCAR now the 45-day review, but I think this can be overcome fairly easily. So in my view, we should engage funding organizations and presentations, engage hydrometeorological services and educational institutions in targeted countries where we have existing relationships. Prepare high-level presentations showcasing capabilities with a focus on how our tools have enhanced the accuracy of early warnings in different fields in the past. And then also in terms of the research application program, which has been very active in this area, to work with stakeholders. And we will be having additional meetings with the World Climate Research Program Conference. We will have meetings in the second week with different African countries talking about some of their needs during that period. And then logically getting WMO and other international organizations on board, start engaging more with the national meteorological and hydrological agencies where we have connections, and then develop a plan to initiate dialogue with funding agencies in a more holistic manner than we have done in the past. And I think I'll leave it for there. I've been rambling for quite a while now, so I'll leave it at this moment. Thank you.
Thank you, Roelof. I think that we have a couple of questions on Slido. So, yeah, Kelly, if you want to read them out.
Yes. Thank you, Roelof, for such great presentation, truly highlighting the challenges, and it's also encouraging how you really reflected on where we can actually be able to contribute as an international community. Let me quickly go to the Q&A in Slido. The first comment is from Dr. Oi Ideki. He's asking to please provide the presentation slides. I'll say that the presentation is being recorded, and if that's not sufficient, I would say to directly email Dr. Roelof. And then the next question is from Leanne Simpson. She says, I agree that capacity development is a very important aspect in Southern Africa. An example would be the improvements in NWP and ensembles in particular. Are meteorologists and forecasters in Southern Africa countries being trained to effectively exploit the latest developments in this area?
In South Africa, I can comment on this. There are several universities, University of Cape Town, University of Victoria, University of the Northwest, and Witwatersrand, which are actively involving in this. And I think they are doing a lot of research in this. I think the biggest problem, even in South Africa, because most of the monitoring the infrastructure in terms of measurement infrastructure, stations and radars are conducted by the Weather Service. And basically their problem in terms of being able to maintain this with a sufficient budget, data quality control, you can do the best modeling, but if you don't have good data and quality data and high density data, that makes, you can do ensemble modeling, but data assimilation becomes an extremely important part. And I think most of the help is really helping them in terms of the sustainability of the observational networks. I think this is the biggest part. It's not selling them more stations and more radars, but it's primarily getting those that are there working properly and doing the data quality control. And then I think our NWP would work fine. But I think also Comet is at the moment also doing work in automatic weather stations and looking at this sustainability. But I think from an overall point of view, you know, we at UCAR have programs in radar meteorology. We have programs in other EOL, where we can start training engineers and technicians how to maintain these systems and even maintaining these stations, because these are good stations, but if they're not properly maintained and properly data quality control, we do a lot of data quality control. We have systems and software in place that can do that at UCAR. So I think we have an opportunity there. And from the modeling perspective, like in South African universities, I think there is some good work done, but if this could be done in coordination with really working on the monitoring systems also, it would be great. And this could be developed at other universities. I think people are very eager to learn. We met with people at different universities in Kenya and Rwanda recently. But yes, they are very eager to learn, but oftentimes don't have the tools.
Great, thank you, Roelof. Great points. The next question is from Rajesh Kumar. Excellent talk. Can you please say something about challenges you are facing in public-private partnerships in South Africa?
So in South Africa, and this was in some of my last visits over there, we are working with so this is the other thing, we can start working with big companies. Cisco, for instance, has a big program in South Africa to develop indigenous companies, in other words, Black-owned companies. And last year we started working with one of those companies. It's an IT company, ICT company, and they are now working with the Weather Service. And there is also talk now of basically having these private companies potentially maintain all the hardware systems because of the problem of salaries for engineers and technicians in the Weather Service, where they go to the private sector. So we are in the process of looking into that. In Zimbabwe, I met with the telephone company. Communication is an important component of all these early warning systems. And they are very eager to work with the Weather Service. Actually, the telephone company sponsored some of the automatic weather stations. But then if we have the communications, because the biggest problem for most of these national hydrometeorological services is if they have to they don't have the funding to do the maintenance of getting extra funding. But then also in terms of paying for communications is very expensive. And so if you do these partnerships with the companies, and maybe they can have some ownership of the data, because as we have seen in the last 10, 20 years, data becomes valuable. And there are many private companies, like for instance, in South Africa, mining is looking for data and they are willing to pay for that data. So the Weather Service can have the data for free and they can do their work with the public weather services. But if they provide this for private companies like mining companies, electrical electrical companies and those kind of things, there's a potential for selling these data for very specific applications and for very specific uses. Oftentimes in the past 10, 20 years, weather services were tasked to maybe make money on some of this data. But I think if you work together with a private company, we in the public sector are very bad at marketing our data, but a private company has a better idea of how to market your data.
Thank you,
Sorry.
Roelof. No, it's great. We have a comment from Chris Leonard. He says, for capacity development and training, please come connect with the WCRP Academy at the OSC in Rwanda. We will be launching at the OSC and would love to identify through opportunities for training.
Okay, maybe if somebody can send an email or that would be, we would love to do that, yes.
Wonderful. Thank you, Chris. And then finally, Ron, in Africa, it's likely that there are thousands of animal deaths from lightning. Dr. Miriam Cooper and I plan to present a future seminar for the UCAR Africa initiative. These deaths happen to a few people at a time, but are a large number and not included in the natural hazards community.
That is totally true. So the numbers that I have been mentioning, those are official numbers. In many of the remote areas, we don't know the exact numbers, and the exact numbers never come out. And if it's just a few people that pass away, those numbers are not mentioned. So it is relative there. In the US, we know if there is only a few people, but once it gets into the hundreds, it becomes newsworthy in Africa, which is sad because every life is valuable. And I think so even all these numbers that I mentioned are underestimations of what really may be happening, especially in remote areas and even in some of the cities. And there's other health impacts or which you call secondary type of impacts that can also lead to some of these health emphasis. And I think our primary objective with our thing is to saving lives. And then also secondary is the economical impact.
Right. I agree with that. This is why this initiative is so important. So with that, I thank you, Dr. Roelof, and all the people that provided questions. And so I'll pass it to Anna for the concluding remarks.
Thank you very much, Roelof. I think that we have a lot of points and how to bring all collaborations and get started the work in Africa and initiatives. This was a really interesting talk, and we thank everybody for here to be here, and for those also interesting questions, and for the upcoming seminars that probably we're going to have also. So thank you very much, and well, have a wonderful day, you all.
Thank you very much. Bye-bye.